Fellow mathematicians, we're going to take a look at a complicated and tricky problem on finding the derivative f prime of x by using the limit definition. Now this one is very similar to our previous problem, which is linked down below in the description, so check that out. But the denominator here is a little bit more complicated. One of the best tips I can give to Calculus 1 students is before trying to solve a problem, make sure you thoroughly understand a simpler problem. And here, make sure you thoroughly understand the problem linked down below, and that's where we went through this for the function f of x equals 1 over x. Here, our denominator is just a little bit more complicated, but it's pretty much all the same work, subtracting fractions using a common denominator. So let's again take our time with this one. All right, first step, we're going to plug in x everywhere with x plus h. All right, that's really simple here. We only have a single x in our function in the denominator. And I'm going to use parentheses. And we get to there. Now you can leave your denominator written like this with a set of parentheses, but it might get a little awkward and cumbersome and tedious to write when you go to the next step and you start to combine fractions using a common denominator where you might have multiple sets of parentheses inside of one another. So I'm just going to decide to distribute that 3 and write my denominator as 1 divided by 3x plus 3h plus 1. There's a lot of different ways you can write your work here. This is just how I like to do it, and a lot of my students tend to find this to be simpler as well. All right, so that's it for step 1. Now we're going to move on to step 2, taking that expression and subtracting the original function f of x. All right, so we have f of x plus h, and we're subtracting f of x. And this step is where all the work is for this problem. So we have f of x plus h, which is this fraction 1 divided by 3x plus 3h plus 1, and we're going to be subtracting f of x. And we're subtracting here 1 over 3x plus 1. All right, it's the same work as the previous problem. Again, that's linked down below in the description, but your LCD is going to be a little bit more complicated here. So let's go ahead and write that down. All right, and our LCD, we're just going to multiply those two denominators. And we'll write this as 3x plus 1 times 3x plus 3h plus 1. All right, now that's the common denominator that we want for each of these fractions. We're going to have to multiply and divide by the missing factors to get that. So let's go ahead and write that down. Again, taking our time. This first fraction, we're going to need to multiply the numerator and denominator by the missing factor of 3x plus 1. So I'm going to take my time to write this down step by step. We have that fraction, but I'm going to multiply the numerator and denominator now by the missing factor, 3x plus 1. All right, we're going to go to the next fraction. We're subtracting. One over 3x plus 1. That contains in the denominator 3x plus 1. So we're going to need to multiply the numerator and denominator by the missing factor that we want, which is now 3x plus 3h plus 1. And we're multiplying that to the numerator and denominator. And notice what we're doing here. Each of these steps there, we're multiplying by 1, a quantity over itself. All right, at this point, you should now have the same denominator. It's okay that the factors due to multiplication are maybe in different orders, but you have the same denominator. Now what we can do is go ahead and subtract the numerators, and again, because we're subtracting something with several terms after the minus sign, we're going to use parentheses. So I'm going to put them right there. All right, let's go ahead and again take our time with this. And you don't have to multiply out those denominators. So a tip we gave in the previous problem, I'll write it down again. We're going to keep these denominators factored. It's not wrong to multiply them out, but it's just going to be a little bit of unnecessary work. All right, so let's take our time. We're going to basically multiply the numerators there, and now that we have fractions with the same denominator, we can subtract the numerators. So we have 3x plus 1. Now minus, and be careful, make sure you use parentheses. There's a very common sign error that can occur here due to the subtraction sign and then the several terms in the numerator here. So we have minus, and then 3x plus 3h plus 1, and that's all over. I'm going to write my denominator in the factored form, 3x plus 1 times 3x plus 3h plus 1. All right. I'm also going to mention another common mistake that can be made, which occurs right here. You have 3x plus 1 in the numerator and denominator. Same with 3x plus 3h plus 1. However, those are factors in the denominator. They are not factors of the numerator. That's due to the subtraction sign there. So you're not able to cancel between numerator and denominator any factors out because there are no factors in the numerator. All right, but what we can do is distribute that minus sign. And I'm just going to write all this out. Again, we're taking our time. So we have 3x plus 1. And now that subtraction sign, we're going to use it and distribute through the parentheses and change all the signs of the terms in the parentheses. So minus 3x minus 3h, and then minus 1. And again, we're keeping our denominator factored. So 3x plus 1 times 3x plus 3h plus 1. All right, and what you should find now is once you fully simplify this, your consistency check kicks in. Your numerator should contain a factor of h. And let's check here. If we cancel terms out, you have 3x and 3x, those cancel. And you have plus 1 and negative 1, those cancel. And it looks like what we're left with is in the numerator, negative 3h. That does contain a factor of h. All right, and that is most of the work here. We get for our end result of step 2 in the numerator, negative 3h, and then we have our denominator here in factored form. 3x plus 1 times 3x plus 3h plus 1. All right, and here, that is almost all of the work. If you got through this on your own and you fully understand all the steps here, you're in great shape to do very well in your Calculus 1 course. All right, we're at step 2. Let's keep going to step 3. You already can anticipate what we're going to do because our function is a fraction. Instead of dividing by h, which would give us fractions within fractions, let's equivalently multiply by the reciprocal, we're going to multiply this by 1 over h. All right, so we're going to write this down as f of x plus h minus f of x. This is over h. What we're calculating here, this is called the difference quotient. But when we actually now calculate that, instead of dividing by h, we're going to multiply by the reciprocal. All right, and we multiply by 1 over h, the end result here from step 2. And just take your time to write everything down. We had in the numerator negative 3h, and then in the denominator 3x plus 1 times 3x plus 3h plus 1. And you can see here why we wanted to equivalently multiply by 1 over h is it makes it much more obvious that you can cancel those factors of h out. And what we get here for our fully simplified step 3 is negative 3 in the numerator and the same factor denominator that we've been writing down through the previous steps. So our denominator is still 3x plus 1 times 3x plus 3h plus 1. Now we're ready for our final step. We just need to take a limit as h goes to 0, and because the indeterminate form canceled out right here, the factor of h's cancel out, we can evaluate our limit just by plugging in h is 0. So if we go ahead and write this all out, we're almost done. We take a limit as h goes to 0, and we're taking the limit as h approaches 0 of this expression, the end result of step 3. And again, just take your time and write this all out. We had negative 3 in the numerator and that same factor denominator. All right, and now we're just going to evaluate this limit, which make sure you see there is no more indeterminate form. So we're just going to plug in h as 0. And this set of parentheses will simplify to 3x plus 1. So let me go ahead and write this out. We have negative 3 in the numerator, and in the denominator, 3x plus 1. And times now, when we evaluate or plug in h equal to 0, that set of parentheses also becomes 3x plus 1. And you can leave your answer like that, but the standard way to write this answer, we have a quantity being multiplied by itself. We can write it as that quantity squared. So let's write our derivative as negative 3 divided by 3x plus 1 squared. And that is it. That is our derivative for this function, 1 over 3x plus 1. Like in the previous problems, let's just write down our answer triumphantly because we got through this. We have our function f of x as 1 over 3x plus 1. And we crushed and destroyed this problem to get our derivative here, f prime of x, as negative 3 divided by 3x plus 1 squared. And there we go. Now, this is a really good problem to be able to understand, and if you can get through this on your own, again, you're in really good shape to do well in your Calculus 1 course. Hope you enjoyed the problem. I hope you learned a lot from it. If you did, support the channel, like and subscribe.